Among the many reactions that alkyl tosylates derived from alcohols undergo, one of the most interesting and kind of unusual ones is the reduction of alcohols. The reduction of alcohols ultimately gives us alkanes as products. And while one might think that this is a pretty useless reaction since alkanes are unreacted compounds, oftentimes we have a desire for certain specific alkane, but if those alkanes are not available in the naturally available pool of alkanes which comes from petroleum, then we're kind of stuck. We need to produce it from something else. And for producing these things, we need to introduce first functional groups and then completely remove them if we want an alkane. So to go from an alcohol to an alkane, we can do several different things. One thing that we could do based on the knowledge we have so far is dehydrate this alcohol to get to an alkene, and then hydrogenate this alkene using platinum or palladium-based catalyst to get to an alkane. But now, formation of alkyl tosylates gives us another option for achieving this transformation. And so if we first produce tosylate from alcohol using tosyl chloride in triethylamine and methylene chloride, then we will get this tosylate. And in the second step, if we do a lithium aluminum hydride reduction of it, and this is a combination of something we learned in our previous lecture, we can use this as a source of H-, which will basically nucleophilically attack tosylate and displace the tosylate with hydride. This is another way to get to alkanes from alcohols, and it arguably has two advantages over the first route. The first one is that we don't use acid, so we cannot induce any rearrangement. And the second one is that we avoid using hydrogen, which is a flammable gas. It's a little cumbersome to work with. This route allows us to work entirely in solution and produce alkanes through mild methods. This was one of the reactions of alcohols which is often overlooked, but it does have some importance I wanted to highlight.